Dear colleagues, dear friends, we would like to welcome you to this Moses session of the Connecting EU Insights event, the December edition. The title of the Moses session is Technologies for Sustainable Social Shipping, Do Automation and Autonomy Add Value. And Moses, this is an EC-funded project. Moses stands for Automated Vessels and Supply Chain Optimization for Sustainable Short Sea Shipping. I will share with you for the introduction the agenda of the event. Yes, the agenda of the event. And as you hopefully can see right now, we have some very interesting discussions, always focusing on the short sea shipping side and its conjunction and its, let's say, relationship to autonomous and automation operations. We have with us, and I would like to welcome Professor Rudy Negenborn. Then I would like to welcome Mr. Hans van de Broek. Professor Rudy Negenborn is from Delft, Technical University of Delft. Hans is also a member of the Moses consortium, and he comes from TNO. Then I would very much like to welcome Stefanos Kokorikos, another member of the Moses consortium from CORE. And the final presentation will be done by Yannis Kanelopoulos, a colleague of mine from the National Technical University of Athens, from the School of Electrical Engineering. We will close this Moses session with a brief yet very interesting, I hope, discussion with the panelists on a specific statement which has to do on the fact that the interconnected world of 2050, so we're talking about the future, logistics chains will be much more than resilient, and I would ask their opinion and their point of views on that. So without delaying anymore, I would very much like to welcome my colleague, Rudy, from Technical University of Delft. I'm very, very, very happy to have you here, Rudy. You will be talking on smart shipping, the perspective and challenges. So for the next 15 minutes, the floor is all yours. You can share your presentation. Thank you very much.
Yeah, thank you very much, Nicolas. Great to be here. Thanks for the invitation, for sharing some of the research directions that we're pursuing at TU Delft. And since this is interconnecting EU insights, I've in particular linked to several ongoing and past European research projects. So my name is Rudy Negenborn. I'm a professor in the Maritime and Transport Technology Department. And my talk today is about smart shipping, perspectives and challenges, which is, I think, a nice opening for today's session. And really it's about anticipating the massive introduction of sensing, actuation, communication and computation technology. So let me move to the next slide. Yeah, there it is. So what is it about? The research lab Autonomous Shipping. That's the lab under which we bring together a lot of autonomous related research. We work on adaptive control, human-machine intelligence and interaction, real-time optimization of transport and logistics, and experimental validation using high-fidelity simulations, as well as small-scale vessels and real-life vessels in collaboration also with industrial partners. As you can see here on the slide, a lot of the research is funded by national or European funding agencies, with which we work together with academic partners as well as industrial partners to solve futures mobility and transport over water challenges. So we take hereby a multidisciplinary approach that enables green and autonomous waterborne transport, not only on the open oceans, where often you have a lot of space, but the conditions can be quite wild with storms and highly fluctuating water levels and waves. We also look at crowded port areas, inland waterways, as well as metropolitan and urban areas. And in each of these different domains, we ask ourselves the question, okay, how can we use sensing, communication, control and actuation technology to improve the operations, possibly by removing the role of the human operator or moving it onshore or in a control station. We adopt hereby a multidisciplinary approach in the sense that it's not only about technology and marine engineering, but it's also about regulations, about business models, about embedding in logistics, ethical questions, as well as human factors and tracing. So starting from the individual single autonomous vessel, actually there are quite a lot of groups worldwide and projects working on autonomizing, making smarter individual vessels. We are also working on that in the research lab, in particular focusing on new technology for machine vision and situational awareness, predictive control methods for maneuvering control, as well as predictive control methods for thrust allocation and energy management. Here you see some nice works that we did together with MIT and AMS in the rowboat project relating to autonomous shipping inside the metropolitan area of Amsterdam as an example. But this is about the individual autonomous vessel. Where it becomes really fascinating from our point of view is if you zoom out a little bit and you look at the autonomous vessel in relation to its context, where you see a lot of other traffic. This is a picture from marine traffic that shows for a specific day all the ships that are simultaneously moving around in the Rotterdam Delta area. So instead of only focusing on advancing the state-of-the-art on autonomous vessels, we in particular focus on multi-vessel interactions. Yeah, so how to design the multi-vessel interactions at the operational level. What if ships could talk? If they could, more than they are doing now, exchange information? Could they, for example, as in this example shown here, share in real time, in an iterative way, the different paths that they are planning to take? And these paths, they may have optimized them locally, taking into account energy, emission sustainability, as well as logistical efficiency goals. At the same time, they should choose the paths such that they are not colliding with each other. So here, as a nice illustration of this, at each time step, both ships exchange what predicted paths they would like to sail on ideally. Now, what is optimal for one does not need to be optimal for the other, because they might need to collide at some point if they only do what is optimal for themselves. So they reiteratively replan their paths depending on what the other wants. Now here you also get the question about the COLREGs. They're the regulations for preventing collisions at sea. How can we embed such regulations that have been made for human interpretation in automatic control and navigation systems that can be used on board of smart ships? Should we, in fact, include all these regulations, or are some not necessary because they are really made for human interpretation and they are less relevant if you have very frequent interaction between automated systems? Interesting questions that are being addressed in this European Union-supported Interreg project Avatar. Another project that actually finished last month is the NoviMove European project, where the concept of vessel trains is investigated. So here the central idea is, if we are moving larger amounts of ships over the inland waterways, why not cluster them? This could lead to better use of the capacity on the rivers. It could lead to better throughput performance at locks, because not all ships are arriving there at the same time, but only batches of ships that can quite easily go through these lock systems. And it could, depending on the configuration of the ships and how far they are and how they're positioned with respect to each other, also potentially lead to energy savings. So the NoviMar project has investigated different concepts, also looking at this from the business perspective. Here it's about interaction between ships that are not physically coupled. But what if we're looking at object manipulation on the waterways? We have here a large object, like a container ship, that needs to be manipulated by multiple tugs. Very difficult to do that, especially when approaching the port area and the terminals where there's a lot of other traffic. We are developing methods that look at how to optimize the movements of the tugs, how to exchange information between the tugs and the object being manipulated, such that it most effectively, as a whole constellation, multi-vessel system, moves from its origin to its destination position. Of course, taking into account that there can be dynamic obstacles, as shown in the animation here, as well as unknown disturbances due to currents that are changing, waves, winds, etc., that are fluctuating. Then zooming out a little bit, not only focusing on the individual ships and the direct neighboring ships, what if we look at the port area? That is also in the Moses project, the central area of studies. What is the role of the humans going to be? Will the ships be controlled by a captain that is basically just put on shore? Or will this become a kind of a supervisor that is overviewing the movements of a lot of ships and only interacts when there's really a need or when there's a dangerous situation emerging? What about the interaction with the other pieces of equipment, like the cranes and the AGV systems? Are these human operated, or are they also replaced at some point for efficiency reasons by automatic systems? And how will these interact? We've been studying this together with international partners, and also the recently started H2020 program MAGPIE really focuses on different aspects of port areas and introduction of all kinds of autonomous systems and their interactions. Now, zooming out a little bit and putting things in perspective, because it's not only about making things autonomous. In the end, what we think is important is to improve the way goods are transported. So we look at autonomy over water in function of a smart logistics setting. And in the NoviMove European project, we work on smart and sustainable waterways with as goal to make better use of the capacity of inland fleet and infrastructure, in the end to increase inland waterborne transport reliability and competitiveness. We work at this at different levels, starting from new designs of climate resilient ship concepts. Climate resilient in the sense that they can better adapt their own shape to fluctuating water levels. If you look at the main corridors, waterborne corridors in Europe, the water levels can vary quite a bit, very low, very high, fast or slow currents. And you would like to have some ship designs that can kind of adapt to this such that the capacity doesn't drop too much depending on the waterway situations. And on board of these new climate resilient ship concepts, we of course also include new smart navigation systems based on these concepts from autonomy that I just talked about, also being inspired by the other projects, and also adding to this new Galileo network, a satellite system empowered positioning systems. Then moving a little bit outside of the scope of the ships, we also look in NoviMove at new terminal concepts and cargo reconstruction concepts. A lot of the cargo that is being transported in containers is not transported very efficiently, in the sense that the loading rate or filling rate of these containers is not always 100%. In what situations can you repack containers, and how do you include this in existing warehouses and terminals? And when do you unpack these again? This is part of the new NoviMove terminal concepts. Well, having new ship concepts and new terminal concepts, we also look at the interaction between ship and terminal when it's about floating mobile terminals. When should a ship arrive at this floating terminal? How should this floating terminal unload the ship and again reload other shuttle barges that are moving towards the traditional fixed location terminals? And then starting from analysis of the current situation, in particular here around the Rotterdam area, and then focusing on 2010, we also develop models that can provide a high level of realism to evaluate the possible impact of the NoviMove innovations in terms of ship designs, navigation systems, and logistical concepts for future situations. So we kind of create an a la carte tool with which you can select innovations. You can provide scenarios regarding demands and evaluate what the longer term impact will be. Now, to move from concept and innovation towards future implementation, we focus on the Rhine-Alpine corridor, of which the 22 partners involved in this project also have a good relation, which is a very interesting system because it's large and very complex. It has a high number of ports and terminals. It spans across 5 countries, 3 different transport modes, barge, truck, and railway, many operators with different objectives and numerous skippers exhibiting different behavior. Of course, they are all interacting, and how to get from innovation and concept, of which we can show the impact in our analysis tools, towards implementation that really requires this multidisciplinary approach that I mentioned in the beginning, to move from science towards application. Well, this is only in total 15-minute talk, which is very short to just give you all the details. So I would like to recommend you, if you're interested in these topics, take a look at this position paper on smart ships and the changing maritime ecosystem. It mentions several of the topics that I've talked about today, as well as this recent position paper on AI in the maritime sector, which highlights the main directions that the Dutch maritime industry foresees in the future and the role that AI has in this. Besides this, there are also 2 books that I would like to bring to your attention on distributed model predictive control that kind of encapsulates this idea of ships talking to each other, exchanging their plans and adapting in an autonomous way their plans to find consensus, and a nice book that covers latest insights on transport of water versus transport over water. Now, we have noticed at the launch of Novimove that there are several other large European projects that are all focusing on optimizing smart logistics or smart shipping operations. And this led us to initiate the joint inland waterway transport smart logistics and smart shipping project initiative. These projects have already joined this initiative. Basically, this means that we organize at several moments alignment activities, and we see where we can benefit from each other's directions and insights, and where we can perhaps also later on organize joint activities. And you are most welcome to express your interest in joining this initiative if this relates also to your projects. Having said that, again, thank you for the invitation and in letting me introduce smart shipping perspectives and challenges. I'm most happy to provide you more information about the different Interreg and H2020 funded projects, and bring you also in contact with the principal investigators that are involved in these different initiatives. So thanks.
Thank you very much, Rudy. I think it was a very, very interesting and very explanatory, self-standing presentation. Very, very exciting work that you're doing. I have already seen parts of your work back from China, yeah, everything. And I think that perhaps Moses can also be part of this, of this initiative that you are discussing. And I will send you an email within this week to let you know how we can proceed, to ask you how we can proceed.
Yeah, okay. That will be great. Thanks.
Very nice, very nice. I do not see any question. Let me just, pose my thought here. How do you think, there will be at some point, perhaps not so quickly, but there will be a mixture of conventional ships, of remotely controlled ships, of autonomous ships, etc., and they will be all, at the entrance of the port of Rotterdam, at the port of Piraeus, or whatever. Can you give us your thoughts on that?
Yeah, so I agree. I'm often asked, when will we have autonomous ships? And then, yeah, okay, yeah, that depends. But for sure, we will not have very soon a situation in which all ships will be autonomous. And even if that would be the case, then they would all have different degrees of autonomy, or different manufacturers, different protocols. So we actually recently also started to identify all the moments at which ships interact with humans. So where is the human interaction taking place at the moment? What we would like to have in the future is that an autonomous ship that, for example, in the port of Rotterdam, which is putting a lot of effort in digitization, there it might be possible to more autonomously dock and undock and move away. But we do not want this ship to be restricted to operate only in the port of Rotterdam. It should also be able to move to other parts of the world where perhaps autonomous ships are not facilitated that much. So in these situations, you would like that the autonomous ship can somehow mimic the way in which the human is operating or interacting with human operators in these other port areas. And how to do that, I don't know, but I do know that we do have to take into account the role of the human operator also in the future, and a lot of different scenarios and settings for which it has to be considered. It's not a closed area like one terminal where you just can have your AGV system running around. It's a much more open and broader space.
Thank you, Rudy. Thank you very much. Thank you for the very interesting presentation.
Thank you.
Thank you. Let me. Okay. Let me share again the agenda. So the next item will be a very brief, it's only less than 5 minutes, a very brief presentation of the Moses project. Actually, the title is Moses at a glance. So let me share this presentation in order for me to explain very briefly the concept of Moses. Okay, hopefully you can all see my screen right now. Okay.
Yes, please. So can you put in presentation mode?
It's not, sorry for that.
No.
I hope that now it will get into the presentation mode, okay? As I said, we will have a very brief overview of the Moses project. The Moses project, actually, it started back in July 2020. So as we all understand, right now we are just before the midway. And the interesting thing is that now we have the first deliverables coming out, the first results coming out from what we call technical work packages, the technical work. So hopefully very soon we will also have more, specific results to show than just showing the concept. But for the purpose of this presentation, we will be focusing on the concept of the project, the automated vessels and supply chain optimization for sustainable resources shipping. The consortium comprises 17 partners, and you can see the geographical spreading of these partners. We have partners from Cyprus, from Greece, from Italy, Spain, from the Netherlands, Denmark, and Sweden. So the concept actually with Moses, we have promised quite a lot of things, and the Commission expects from us quite a lot of things. First of all, we have what we call.
Sorry, Mr. Venticos.
Yes.
We always see the first slide. I don't know if you go on the second.
Yeah, I have changed. Hang on a minute. Let me unshare and reshare.
Okay.
Hang on a minute. I'm unsharing and now I am resharing. Let me see here. Share. Can you see?
Okay, now it works.
Okay. Okay. So the concept, as I was explaining, comprises, first of all, what we call the Moses autodock system. So this is a combination between a swarm of autonomous tugboats plus an automoored system. So we are not messing at all. We are not handling at all. We are not changing anything on board the mother vessel, the big container ship, but we are focusing at the very last phase of maneuvering and docking of the ships. The second innovation, as we call them, is the Moses recharging station, which we will be discussing because Moses project foresees the design in a conceptual level of an innovative feeder vessel. You can see it over here, the innovative feeder vessel, which at the end of the road will be, as we understand, an electrical moving and propelled vessel. The innovative feeder vessel, which goes from the main hub, from the deep sea port to smaller ports, to ports with none whatsoever infrastructure, hosts on board what we call as the robotic container handling system. And I think that Hans in a little while will have a very good presentation on that. And finally, on top of all this process, we also have what we call the matchmaking platform. The matchmaking platform, for which Yannis will have a very nice presentation later on. Now, our partner from Core, Stefanos, will be discussing about the autonomous tags and the architecture and the way that we see that. On top of that, we also have a control station, a shore control station that handles part of the overall operation, which means the tags and the autodock, whereas there is another control station that handles the various activities of the vessel. So here are once more these innovations and the various parts and bits. The thing is that we had, to be able to serve with this innovative feeder vessel a port that has limited or no infrastructure at all. And this was one of the challenging points. And another challenging point is, as I've already explained, we do not want to change anything on the day-to-day operation of big vessels, which means that picking it up from from one of the points mentioned by Rudy, is that we have, for example, for the interaction between tugboats and the vessel, we have exactly made the complete function mapping of the functions, and we are now deciding which of these will be replaced from the human base to a more autonomous based operation. And this is a very, very interesting work. The objectives, as you can see, they can be technical, they are societal, and also market. And of course, all that they're putting an overall, picture of environmental and reduced footprint. So here you can see some hand-picked objectives. We want to develop an automated maneuvering and docking system for deep sea ports, develop and promote the matchmaking platform, exactly to boost the potential and the operation of sources shipping, and to design innovative hybrid electrical feeder vessel outfitted with a robotic container handling system. Or we can go to the right-hand side to promote port development with minimal investment and develop concrete business cases. There are two business cases with the Moses project, and there will be an open call for a third, not so much business case, but a third northern case in which we will validate our approach. And we want to reduce the environmental footprint for sources shipping and ports and improve efficiency. And at the very end, the end-to-end delivery times exactly to boost the sources shipping mode. So some of the expected impacts for the entire supply chain, and what we have promised is a minimum by 5% the decrease of end-to-end cost for container transport with feeder services, an increase of 15% of feeder traffic between large terminals and small ports. We want to put very small ports and small ports or medium small ports into the game in order to further boost sources shipping activities, and about 10% of the modal shift to increase the modal shift to sources shipping in the various designated areas. And as we understand, the Moses project, we host software development, hardware analysis, procedure development, design, and supply chain analysis. So it's a quite demanding, and as I have explained from the beginning, we have promised quite a lot. And I would like to thank everybody for your attention. I see on the chat, okay, a discussion which I will see whether I can contribute as well. So not losing any more time, the chat is always, and the Q&A is always open for you to place questions and comments. Let me stop sharing, and I would very much like to invite on the floor Hans with his presentation on remote supervisory control for robotic container handling systems. Hans, you have the floor for the next 15 minutes, so you can start sharing your presentation. Thank you very much.
Okay, thank you very much, Nicolaus. I will share my screen. Hopefully it's visible now. So yeah, good afternoon. And with this,
Hans, I can see, I still can see you. I cannot see the presentation.
Okay,
I don't know whether it's only me.
Yeah.
Super. Thank you very much.
Okay, so it's okay now?
Yep, everything is fine.
Okay, so well, good afternoon again. So this presentation is about TNO's research on supervisory control for a robotic container handling system. And for those who don't know, TNO is an independent, not-for-profit Dutch research organization. This research within the MOSES EU research project is mainly focused on enabling a short sea shipping feeder service, the first of the 2 lines of development within MOSES. Well, the robotic container handling system we are developing and eventually will be also demonstrated will be mounted upon the innovative hybrid electric feeder vessel for the short sea shipping leg. And we do this in collaboration with McGregor, the consortium partner who also provides the crane system. Well, the main feature of the MOSES robotic container handling system is that it provides an autonomous loading and unloading service to the feeder vessel. In other words, it does not need an on-site or onboard crane driver or deckhands or a stevedore, nor a safety officer. And this makes the robotic crane a key innovation for enabling a short sea container supply chain independent from the infrastructure of small ports. That's very important because all it needs is a key for berthing. So, although robotic systems will be designed to operate autonomously, its self-sufficiency will not be 100%. That means that there will always be situations in which human interaction is needed. For instance, when it is unsafe to operate because people or trucks are in the operational area, or when an expected container is not there. In these situations, human intervention is needed. As a consequence, for robotic crane operations will be supervised from within a shore control center located at a distant site. Remote operators supervising the remote operations are only involved when problems do occur. This means that the operators are not the replacement of the remote crane driver nor the safety officer. These functions are performed automatically by the robotic crane. And by the way, this picture is taken at TNO's experimental control center facility that also will be used for later demonstration within the MOSES research project. The robotic crane is schematically shown at the bottom right. Based on an advanced sensor suite, the 3D world interpreter creates a so-called obstacle map in which objects such as containers and trucks, but also people can be detected. Based on this, container coordinates will be provided to the auto-drive system to direct the crane and spreader. Also, the operation can be stopped when people or cars are detected within the operational area. Despite this exciting technology, in this presentation, I will focus on remote operators. What we know from research in other domains of autonomous applications is that it is very difficult for humans to concentrate over long stretches of time and to maintain sufficient situational awareness levels to be able to take over control. This is the so-called out-of-the-loop problem. Also, the more reliable and robust that automation is, the less likely it is that human operators overseeing the automation will be aware of critical information. In addition to that, in the Shore Control Center concept, it is efficient that several remote operators will be responsible for multiple loading and offloading operations. So keeping track of critical information and overseeing all operations becomes increasingly difficult. To overcoming this problem, an artificial intelligence operator support system is being developed. An intelligent operator support system, abbreviated as IOSS, is a system that supports remote operators in their supervision and control of multiple robotic container loading and unloading operations. The IOSS consists of three main functionalities as shown here, which I will explain shortly. One of the foreseen functions of iOS is to manage the Shore Control Center, is to assign the right operations to the right operator. We do this by planning operations continuously based on operation difficulty, operator experience, and operator workloads. This means that if a new operation is registered, it will trigger an allocation process where one looks at which operator has the skills and the time to take on the operation. In addition, operators can disagree with this allocation and flag an operation for rescheduling, triggering the allocation process again. If an operation reallocation is reallocated multiple times, so nobody takes on the operations, it is put to review to the human team lead. Okay, so the second functionality of IOSS is to continuously estimate relevant risks to every ongoing operation. This allows IOSS to timely make the assigned operator aware of an increasing risk or an increasing probability of a high impact risk or safety or on safety or efficiency. So in this project, we are not going to make an inventory of all the possible risks, but rather develop a framework to how to inform operators about the risk and to support them to take mitigating actions to deal with it. For the Shore Control Center, we assume that operators are not busy supervising an operation all the time in very much detail, rather staring at the video stream, for example. Instead, we want them to only be involved when human approval is needed for starting an operation, or when there's an error or situation that the crane cannot solve on its own. However, we also know that humans are prone to micromanagement and especially to systems they do not fully trust. This is why an operator can progressively zoom into a higher level of system detail I will now present some slides that will give you an impression of how the different levels will be shaped. So this is the view of the operator on fleet level. So this is the fleet view, and the journey status of 5 imaginary ships are projected. And this indicates that that an operator or that a ship is in transit. This indicates that the ship is berthing. This indicates an offloading operation, and this is a loading operation. And here below you see the estimated workload of, in this case, Otto, the operator in charge, and when multiple operators or loading and offloading operations occur simultaneously, then the workload of the operator becomes the highest. And when the workload gets too high, for instance, when an unexpected problem occurs, ships can be reallocated to operators that depicted below. And here you see the other operators and their attached workloads. Well, we can elicit additional information to hover over the interface elements. Here you see the expected end time of the operation and the expected end time of leaving the port. Well, this is an example of ISS reporting a camera area on one of the systems on which the operator needs to take action. This is an example in which rescheduling is acknowledged. Yeah, that's something also the operator needs to know in this instance. And this is a example of flagging a problem or a request transfer of the vessel. When the operator thinks he can't handle the situation, he can transfer the ship to another operator. Well, the example we are now going to look at is the ship level, on which is zoom in on information and tasks that is related to a single ship. So in this case, the La Spezia. And well, the information and reports will be projected in this middle section. And here we see also the concept of progressive disclosure, because an overview will be presented here. And but the operator can still zoom in on the tabs to see more information into detail, etc., etc. So from within this ship view, the operator can switch back to the fleet level view, but also can switch back to the immersive view. So let's do that. Well, the immersive view is very much work in progress, and this picture shows an experimental setup of the sensor suite at the TNO location, and the height and the angle of which the park cars are, which represent containers, by the way, are comparable to the position in which the cameras will be mounted on the crane. And the 3D World Interpreter software identifies the containers indicated by the frames. And also in different scenarios, we add people walking around and cars passing by, like here the blue car on the tarmac. Well, and because of bandwidth issues in reality, it's not simply stream the video feed from the local port to the operator. Instead, we want to provide the operator information in a way that will take up less bandwidth, but is rich enough to enable situation awareness. So in this picture, the yellow rectangular represents the containers. The black box is a static object, in this case a tree. And the squares are people walking around. You can here see the blue rectangulars. Here are people walking around. It is not that good visible, but they are there. And so the dynamic car here is the dynamic object is the blue car here. So what we want to do initially, what we strive for in the end, is to create a digital model, a digital twin, as you like, of the local environment, like you can see here, in which the dynamic elements, like the containers and the dynamic objects, can be projected. So we need the structural elements are fixed, but the dynamic elements can be inserted, as it were. So, well, we currently are preparing a large experiment to find out to what extent subjects can build up situational awareness, or based on the 3D model compared to the real world feed. And here you see an example of a task a subject needs to complete. And of course, the same task needs to be executed also with the digital twin. So taken all together, it means that we eventually need to create 3D models of the loading and offloading area of the individual local ports. And the one at the left is a simple model of the Mykonos key. And well, we are particularly interested, of course, to the stretch of key on which the containers will be placed. And here also you see a static element and where the containers would be projected. So this would be the area where the containers could be projected. And yeah, here you can see eventually cars passing by or people walking around. So that's the basic idea. So write the local key situation that will be projected in the 3D operational model. What is the immersive view of the operator? So yeah, I think this is it for now, because well, I only had 15 minutes. Well, we hope to provide you a final demonstration of the intelligence operator support next year. And I hope we can show you more work in progress next year. So that's it for me. Thank you.
Thank you very much, Hans, for the very interesting presentation. I do not see any Q&A. Let me just ask Hans, I guess that situational awareness, it's a very, you know, key here element. I mean, for the people from the remote control to have a very good picture of what's going on site. If you can elaborate, you know, just for a few seconds, it would be super.
Yeah, that's essential. And like Rudy Negenborn already also said, in our concept, we only want to involve operators when problems do occur. So, of course, the 3D world interpreter can detect people or cars driving around or walking around, so the operation can be stopped. And then the operator can take a look, an immersive look, and see the local situation through the 3D model, and to see whether or not the situation is indeed unsafe. And if it is so, well, within the concept, we envision that the operator can take up contact, communicate with the local port authority, which also can have a 3D model of the port, or can be at site, and ask the local port authority to intervene and to move people or cars out of the way when they are in danger. So that's the basic idea. And well, also the situation awareness, that view, that model will also support the system in reading container IDs when there could be a mixed up when container IDs are not that good readable anymore. Then also the operator can zoom in and help to detect the right container IDs, etc., etc. And the same holds for well, missing containers and other situations that are beyond the problem-solving capability of the crane, the physical crane itself. So that's basically the thing. And yeah, the reason we want to build the 3D model and to already model the structural elements up front is to reduce the bandwidth between the local ports and the location at which the operators are located. So that's the basic idea.
Yeah. Okay. Thank you very much, Hans. Thank you very much. I guess that now we can move on to Stefanos Kokorikos from CORE, and his presentation is titled Autonomous Tugboats for Efficient, Eco-Friendly and Safe Port Operation. CORE is also a partner from to the Moses project, and Stefanos is heading the company. So Stefane, the floor is all yours.
Thank you, Nico, and also thanks to the host for having us here and giving us the opportunity to talk about our work in the Moses project regarding the autonomous tugboats and how they can indeed lead to more efficient and greener and safer operations in the port environment. So my name is Stefanos Kokorikos. As you see, I'm the co-founder and the managing partner of CORE Innovation. And just to give you an idea of who we are and what we do, CORE Innovation was founded in 2016, so we are 5 years old. We have been quite intensive in our work in research and innovation. That was also behind the building of the company, was the fact that we wanted to give the people and organizations the opportunity to reach their own potential. And in this field, well, with this in mind, what we wanted to do in our business priorities was to work on machine learning and several artificial intelligence technologies in order to achieve exactly that. So in the last couple of years, we have made a switch to the company to a more commercial profile. We are now commercializing our first product, which is in the predictive maintenance field, mostly in the manufacturing sector, but also with applications, and we are doing some pilots in the shipping industry. We are also working in energy management and optimization. Also, this is being applied in several fields. And in the research, one of our research fields is swarm intelligence in several robotic applications. And in this context, we are coming to Moses, which is, well, it has given us the opportunity to expand this expertise in, let's say, embedding intelligence in autonomous vehicles. So exactly that is our main, let's say, focus in Moses, to build a holistic solution for autonomous vessel towage operations. But first, let's say why where we need, the world needs autonomous tugboats. Well, we consider that our work is a step towards decarbonization of waterborne operations. Really, we're talking about the technologies that can potentially lead to a reduction in fuel consumption and also as a result to the reduction of greenhouse gas emissions in port operations. Let's not forget that tugboats are operating in a very harsh environment in large ports where there's increased volume of traffic, especially in the last years, and they are exposed also to weather conditions, having a big impact on the pollution of the port area as well as the urban environment that is surrounding it. So to be more specific, what we are developing is systems that can make greener the tugboat operations. And in this context, of course, we need to be able to validate our work in Moses. So we are monitoring several key performance indicators that are also relevant to other systems that are being developed in the project. Hans mentioned one of the systems. So what we are monitoring is how we are going to reduce the cost of port operations, also the reduction of docking and maneuvering times for the large vessels that are coming to moor inside the port. Also, how we are going to reduce the human error accidents in ports. And at the same time, as a last, let's say, impact of the project is how we're going to engage small ports to be acting as container terminals in the future. So what we're doing in order to be able to succeed in this is we are using a set of enabling technologies. One of them is a state-of-the-art simulation environment that we are building from scratch in Unity 3D system, which is basically a graphics engine that is used in the gaming industry. So there we are modeling the whole operating environment of the port, including water physics, as of course water and the environment is mostly affecting the movement of the boats. We're doing this, of course, with our partners in the project. So here you can see an example of the port of Piraeus and how we're building, using several technologies. We are building a virtual port environment. Also, examples of a virtual tugboat and a virtual container ship. Why are we doing this? So we consider that this simulation environment is it's a virtual space that is enabling us to test and demonstrate the operations of these autonomous tugboats. And in order to do that, we need to embed into these ships the intelligence to be able to operate on their own and also to communicate with each other. Of course, there has been a lot of work being done both in hardware and software, let's say, analysis and the architecture of the system. But we are, as a core innovation, we are also working in this swarm intelligence, let's say, system. So for this, we are using reinforcement learning, which is one. Let's say, oh, sorry, master. Okay. So reinforcement learning algorithms, which is a machine learning training method that is being based on a rewarding system for the operating agents. So basically, we let the tugboats act on their own, and then we give them rewards when they are doing things correctly. For sure, it's something that is quite we're quite familiar as humans, because this is basically the way that we are also learning. From our childhood, we have been taught that to be able to learn, we are doing things, and then we have a try and error, let's say, approach, and then we get rewards verbal rewards for example, that we are doing things correctly. So we have also designed some operating scenarios that we are going to use in order to validate our developments. We are discriminating them in 4 phases. The first phase is the preparation for the towing and the berthing process. And then we have the towing and the berthing process itself. Then we have the mooring and also the vessel departure. For this, we have built several personas in order to be able to create the user stories in order to understand also how the things are working right now. And for us, this is important because this can give a real business perspective for our developments. Don't forget that this is a research project, and we are still in the middle of it. So there's a lot of work to be done. And well, what is this work that we need to do? We are working on the integration of a shore control system that is going to be able to give the operator the monitoring and the control of the tugboats, and also at the same time to collaborate our tugboats to collaborate with the autonomous mooring system of the project. And in the last phase of the project, we're going to validate this technology in a relevant environment with our partners in Denmark. Okay, so finally, I would like to show you some preliminary results of our work, basically to understand, to give you an idea of the virtual environment that we have built, and also to understand how the swarm intelligence algorithms work, and you know, some of the results before and after training the tugboats. So in the first video, you will see that, you know, the tugboats are not trained. They are moving without real cause to different directions. You know, the algorithm behind this is giving them rewards or penalties depending on whether they are performing the operation as they would. And after some time of training, they managed to make it and perform the scenario correctly. And the scenario was to push this large vessel towards its berthing position. So as you will see, that there is also the simulation of the water and the surrounding environment. Of course, there's a lot of work that needs to be done in order to be able to have a solid system, and the validation is going to give us, you know, some confirmation of what we're doing and whether this can be applied in the real situation. So that's it from my side. Thank you very much for your attention, and I hope I will hear from you soon.
Yeah, thank you very much, Stefane. Thank you very much, Stefanos, for a very interesting presentation. I see on the Q&A there is a question. So Patrick, I will, and Stefanos, we will reply to the question shortly. Thank you very much, Stefane. I think that we should move on to the next and final presentation of this session from Yannis Kanelopoulos. The title is on Sources Shipping Logistics Matchmaking Platform. It's about the matchmaking platform of the Moses project. Yannis is a colleague from mine from the School of Electrical Engineering. So Yanni, the floor is all yours.
Thank you very much, Professor Verdikos. Let me share my screen.
Thank you, Yanni. Thank you.
Okay, so let me start by making a comment first that in order to have all these things being viable, since they are freight vessels, we need to have freight that's moving around. So we need to make sure that apart from having the vessels moving using autonomous scenario and autonomous operations, we need to have something that will enable the users of the logistics services to be able to cooperate and take advantage of whatever technologies are implemented in all transport modes. So what we are trying to do in Moses is to try to create a logistics platform, a logistics matchmaking platform that will be able to match the demand and the supply of logistics services with a focus on the short shipping, on moving freight, more on the short shipping side. So what is the Moses platform? It's actually a digital matchmaking platform that enables horizontal collaboration among logistics stakeholders that are aiming to match the demand and the supply of cargo volumes. In short, it means that every provider of logistics services will be able to list their services in this platform, and every user of the services will be able to see what is available, the alternatives that are available there, and try to make the best use depending on the needs that he or she has for the movement of freight. As I already told you, the focus is mainly on water-based transport, since Moses is a project that focuses on autonomous vessels. And the main part that will come from the vessel side is the provision of the supply availability, meaning all the routes that are available and all the calls that are available in various ports. That will allow us to have increased availability of available short shipping routes and combined with interland routes in order to be able to make efficient allocation of cargo and move as much as possible of it via short shipping. Of course, in the platform, there is also demand management, meaning that we allow the logistic users of services to cooperate and either proceed with load sharing or be able to provide the necessary cargo for having operations in both ways of transport, either in short shipping or hinterland connections. And finally, we are trying to make an algorithm that will allow us to increase the cargo consolidation cooperation and be able to increase the fill rates of both containers and hinterland connections such as road and rail. The objectives that we have by developing this platform is, first of all, to have a clear mapping of the business-to-business processes within the entire supply chain, meaning that we need to be able to provide the means not only to big shippers, but also to SMEs that are moving freight around the world to take advantage of tools that are not available in the market and are not easily developed by them. Thus, one of the things that we are doing is to try to map all the network that we're having in the areas of interest of this platform and be able to give them the alternatives that are available to them without having to go out and search the entire market about the various alternatives and intermodal traffic modes that they can use in order to reach from one place to another. This way, we assume that we will be able to direct some of the traffic to short shipping, and thus we will maximize the demand for this transport mode, and we will be able to achieve some modal shift from a road that is currently the major way of transport to intermodal rail and waterways, either inland waterways or short shipping. This way, we will be able to also achieve cargo flow consolidation because the capacity of vessels is much larger than the one of both rail and road, and be able to change the freight flows that we're currently carrying partial cargo loads and make it cost effective. This way, we will also optimize the distribution routes, and we will improve the empty container management, which we know it is a major pain point for most logistic operators, that they have to move around empty containers and thus creating not only unnecessary traffic, but also greenhouse emissions that are of no use actually because no freight is transported. The platform audiences, like we say, the users that we have for our platform, they are the shipping agents, the terminal operators, the freight forwarders, the shippers, the tracking companies, and the rail operators, practically any provider and any user of logistics services. The main tasks that they will be able to perform by using the Moses Matchmaking Logistics Platform is going to be to have a list of all the ship and rail routes that are available in order to be able to schedule their transport, to be able to post their own needs so that they can be covered by a transport mode operator. They can place order requests in case there is no available route on the current matchmaking platform and can be replied by providing this route from a transport operator. There will be information about possible matchmaking options in terms of cooperating with other logistic service users in case we have partial loads on either vessels or rails or even trucks, and be able to proceed with order execution and status monitoring of their order. Overall, this logistics platform has as a main goal to provide the means of communication between different stakeholders of the logistics services sector in order to be able to achieve as much as possible cooperation among them. The supported features of the platform is, first of all, the route visualization through web-based georeferenced interface. Every user of logistics services will be able to see on a map the various available routes and intermodal transport alternatives from one point to another, from the selected origin to the selected destination. Each one of the users will have access only to services that are related to their role. Thus, there is going to be a role-based access on the logistics platform, so that the ones that are mainly focusing on the supply of services will be able to post their services, while the ones that are using on the demand side of the logistics services, they will be able to make requests for whatever needs they have. This way, there are going to be scenario building capabilities that users can evaluate and select the one that is best for them based on their own criteria that can be either cost related, energy efficiency related, or the reduction of the environmental footprint, which is getting more and more of interest since the Green Deal is one of the primary goals of the European Union. Finally, there is going to be a specific module for sharing information on empty containers and providing cost-effective solutions for returning them or making a relocation, or even being able to find some cargo in order to load on these containers and avoid the unnecessary voyage back with them being empty. The Moses platform is designed in such a way so that it can be adjustable. Currently, it focuses mainly on two use cases. One use case is the transport of containers from the port of Valencia to the close-by ports of Gandia and Secunda, which currently are serviced mainly by road, and they are excellent candidates of moving from road to short sea shipping most of the cargo that is transported there. And the second case is the movement of cargo from Piraeus to the Aegean Greek islands, which carry a lot of traffic throughout the year, and currently is mostly transported via Ro-Ro vessels in a mixed mode with passengers and freight that's causing quite some delays, especially during the loading and unloading process. By making use of the automated features that are developed in the Moses project, the smaller ports of the Aegean Islands will be able to accept container traffic from the feeder vessels without having to upgrade the infrastructure or make use of any specialized equipment that is not currently available. Although the logistics platform, the Moses logistics platform, is developed mainly with a focus on the short sea shipping, it can easily be replicated for inland waterways transport. After all, the means of transport is practically very similar. The feeder vessels with the barges and for the purpose of the logistics platform is only a means to load a container, while it can also be adapted for the use of any other modular logistic unit, not just containers, and it can drop down to pallet level or even new modular units that are being developed for shorter distances and last mile distances to be loaded on either containers or trucks. This way, it will allow us to adapt to any user scenario that we have and to be able to serve as many clients of the logistics services as possible. Apart from the two use cases that we are developing within the project, there is also going to be shortly an open call requesting one more use case to be developed within the time limits of Moses. And we are focusing on a TEN-T corridor that is not already serviced by Moses, which means it's going to be one of the corridors that will be either inland or in the North Sea, because we are already covering the History and the TEN-T corridor and the Med corridor with the two use cases that we currently have in place. The current state of the platform and what we have already achieved, and we will be able to demonstrate by the end of this January in an alpha version, is that we have managed to include currently 74 ports of the Mediterranean and the Black Sea, with the routes that are taking place among them. For the purpose of this project, we are considering short sea shipping as being the coverage of the Mediterranean and the Black Sea, and not just short distances of a few miles. And currently, the algorithm has a performance that can give results of all the available alternatives in about 6 hours. Now, for this reason, and in order to be able to have prompt responses to our users, we are introducing business rules into the algorithm instead of just plain calculation of the available routes that are out there, in order to make them more feasible and more realistic for the selection of the users. For example, there can be a track that can travel from Piraeus to Valencia, but obviously this is not the optimal method of going from one point to another, and thus we need to eliminate this from being selected from the algorithm in the future. And one more case that we are having in mind in order to investigate is whether it is going to be of use, because this is mostly related to long-term planning of freight operators, to deliver the results of the calculation of the algorithm in a batch mode, so that not to have a real-time, let's say a near real-time analysis of the available alternatives, but rather to deliver to the user of the logistics services in a batch mode what are the available options and their parameters in terms of cost, in terms of environmental emissions, greenhouse gas emissions, in terms of turnaround times, and in terms of when and where are available. The current state is to populate our database with the most current route schedules. We are developing online schedules with the ports that we have, wherever these are available. Wherever they are not, we are using the standard posted vessel schedules from the ports that are involved. And the way that we approach it is using a hub and spoke architecture, meaning that we assume for the purposes of efficiency that a number of destinations is serviced by one or more ports, but not all the 74 ports that are available in the platform. For example, you can always get from Barcelona to, let's say, Switzerland via a vessel, but this is not an option since you have Trieste that is much closer to it. One more thing that we are focusing on is to develop a graphical user interface that is going to be practical for the user and will enable the easy use of our platform. And the final part that we will be focusing once the alpha version is ready is to populate the database with as many historical freight transport data as possible, so that we will be able to both train the algorithm and be able to, let's say, find alternatives and find missing points that are not covered by routes of short-sea shipping and can be easily transferred to short-sea shipping and have some business value for someone to use them. So this concludes my presentation. On the left side, you can see the social media of the Moses project, where you can join us in order to follow the developments of the project, since now it's getting to be more practical, because we have completed actually the discussions and we have almost finalized the way that we are going to approach and develop this project, and we will be able to start demonstrating our results quite soon. So if there are any questions, I will be happy to answer them. So back to you, Professor Vendikos.
Thank you. Thank you very much, Yanni. Thank you very much for the very interesting presentation. I think you gave a good, overview of what people should be expecting from this activity and from this innovation of the Moses project. I would say, because we're a little bit behind the schedule and we have like 10 more minutes to conclude this session, the Moses session, I would start from you, Yanni, and I will go in reverse order. The statement here, in order to fuel up a little bit the discussion of the panel, is that in the interconnected world of 2050, so we are talking about the future, the logistics chains will be much more than resilient. What else they will be, Yanni? What are we expecting them to be? What do they want them to be? But well, just keep in mind that, 1 minute and a half in order to proceed with the other speakers as well. Thank you very much.
Good. Well, resilience is one of the main things that everybody is looking now in logistics, especially with the delays that we are having in the supply chain that are caused by numerous and different effects, like the pandemic, or like the closing of the Suez Canal, or like the falling of bridges due to weather conditions. But anyway, this is one of the things that always needs to be in place and have some contingency planning for logistics services. What I see in the future is the data sharing part. One of the things that is currently not so, let's say, advanced is the way that logistic players are exchanging information among them and are able to cooperate and move on in order to improve the efficiency of logistic chains. The technology is not the important part. It is mostly the business models that need to change so that they allow digitalization and cooperation in various stages of the supply chain, so that to achieve the end result, which is something similar to what we use currently in order to fly from one point to another. Ideally, in the future, someone would just describe the freight that they need to transfer from one point to another, and they will be able to get a set of alternatives like the ones that we are getting now from any, let's say, platform that is providing the available flights from one point to another.
Thank you. Thank you, Yanni. Thank you very much. Going to Stefanos with the same, let's say, with the same question. And Yanni, if you can stop sharing your presentation, would be super. Thank you.
Yes, well, thank you, Nico. In fact, I would say that resilience is something that, of course, it's trending in the last years, especially due to the pandemic. But I would see that we should approach the resilience aspect based on two things. One of them is how we are going to be able to respond to special situations. We all saw that how supply chain was affected both during during the outburst, let's say, of the pandemic, but also during the process due to the increase in the needs of transporting goods, and how this has affected and made it difficult, let's say, to be able to coordinate the logistics chains. And of course, in this context, AI and predictive analytics is something that can bring value. And I think that there will be more and more solutions that are coming to the surface, and they are going to address these issues. But at the same time, I think resilience is a more continuous process, and it's something that we are already trying to address due to the climate change, and how we are going to use the tools that we have, especially in the technology field, since we are here mostly as technology providers, and how then we are going to use these tools to make things greener, and more sustainable in the end. I think that, for example, technologies that we saw today, like the autonomy of vessels, is something that is towards this direction, especially combined with technologies in the renewable energy systems, or innovative energy storage solutions, innovative fuels for the shipping industry. Also energy management systems to be able to optimize the use of energy, because in the end, to be able to reduce the greenhouse gases emissions of the shipping industry, one of the most important part is how to reduce the fuel consumption. So I think these are the two main, let's say, areas that I would suspect that in 2050 things are going to be quite different.
Thank you very much, Stefanos. Hans, we're waiting your statement on and in relation to the statement that we are looking, I'm sharing on the agenda. So Hans, the floor is yours for the next minute or so.
Okay, thank you very much. Yeah, in regard to resilience, so that was the question. I think, yeah, resilience within loading and unloading operations is something you achieve by really a good collaboration between the human operator and the physical system. So it's really a social technical system you design. So and yeah, the cooperation between humans and systems, that's very relevant. So yeah, that's why we at TNO working on human machine teaming subjects. So and it's also how operators get informed. And in our concept, we do not work with alarms, so alarms going off, but we try to communicate between the system and the operator with meaningful messages. So we try to communicate meaning and not so much an event. So that's probably also better for the whole understanding of within the system. So yeah, I think resilience in this regard is really depends on the good design of the human-machine interaction.
Thank you, Hans. Rudy, I'm certain that you have something very valuable to contribute, because from your work, I think you are going towards this direction. So the floor is yours.
Yeah. So looking at 2050, I think that also what we've been discussing today, we see in all kinds of places more advanced forms of decision making, computer systems taking over certain decision making tasks, or supporting humans, and the human moves to the back, only intervening if something goes wrong. And this will continue, because for individual players, it has advantages to develop these decision support systems. But at some point, you also get the question, these systems, they can make very rapidly decisions. And if all these decisions start making very rapidly their own decisions, and responding to what the other automatic control systems are doing, if they don't take it to each other into account, what's going to happen? So either by 2050, we need to have some kind of behavioral norms of how these systems should interact, or cooperation protocols, or perhaps we need to slow down and not allow very fast decision-making processes to take place. Because if it's about resilience, if automatic decision-making systems can very quickly respond to each other, being at the latest internet hubs, as you see with the stock market trading exchange systems, can in a millisecond respond to what other parties are doing. If something similar happens in the logistics domain, you want to be sure that that the proper communication strategies are in place to keep everything running smoothly. So not only resilience, but for sure structured and acceptable interactions between all the different components.
Thank you very much. We heard about, you see, from the various disciplines, we get similar or not so similar questions. We heard about business models, we heard about technology, about interactions. Interactions should be everywhere. Also in safety analysis, we are very much looking into interactions nowadays. And of course, we keep on hearing about the role of the human. The human will be on the loop, in the loop. There are so many terms there, here and there. And I believe that it was a very, very nice, session. I would like to very much thank everybody. Of course, our speakers, starting from Rudy, then Hans, Stefanos, and Yanis. Thank you very much, guys. Very interesting presentations. And of course, all of our audience and attendees. And hopefully we will be able to talk very soon again and exchange such interesting and very nice presentations and opinions. And thank you very much. Cheers.